I did put a couple of notes up there for you, only so that as I talk about them, you kind of see me using the same process over and over. So let's look at example 1. Example 1 gives us 3x minus 2 squared minus 5, 3x minus 2, minus 6 equals 0. Up to this point, you guys would have solved this. You would have given me 9x squared minus 12x plus 4, and you would have distributed this. You would have collected and combined like terms, and then attempted to figure out the quadratic. Instead of doing that, if you can identify what item appears to be quadratic, sometimes it's quite obvious. This one it kind of is. The 3x minus 2 is the item that is quadratic. If I take 3x minus 2 and name it something completely different, it's standard to name it z. Most textbooks will do it that way. Maybe some others don't, but that's how I've always seen it. Name it z. If I replace every time this occurs with z, I have the following. Z squared minus 5z minus 6 equals 0. Okay? Z squared minus 5z minus 6 equals 0. Solve for z. Well, it's pretty easy to factor this one. This one is going to be z minus 6, z plus 1 gives me a negative 5 and a negative 6. All of that equals 0, which means z is going to be negative 1 or positive 6. Z minus 6 is 0, which gives me a positive 6. Z plus 1 is 0, so z is negative 1. Are you with me so far? I don't have the answer. I do have what z is. Okay? This is the value for z. Now, do you remember I called the item that was quadratic z? Well, now I can take the item that was quadratic and equal it with the solutions. Okay? And do the final solution for what x would be. Okay? So 3x minus 2 is negative 1. If I add a 2, 3x is 1. X is a third. If I add 2, 3x is 8. So x is 8 thirds. I have 1/3 and 8 thirds as my answer. Okay? If you check these, you will find that both of these happens to work. Most of the time they do. Okay? Notice they say, the check is left for you. Okay? If you check and plug in, you will find that these do both work. Recall that you've been warned in the past, there are some occasions where for whatever reason you find roots but then they don't work. It's not terribly often, but if it does, you'll have an extra answer. In any case, these two do both work. Okay? So, what item was quadratic? 3x minus 2 was quadratic. That means it was squared somewhere, or it looked like it was quadratic. Call that z, plug in the z values where that item used to be, solve for z, and then plug in that z value for the substitution that you had. X then is the two solutions you've come up with. Example 2 is also pretty straightforward. It's a fraction, which I think makes it a little more difficult, not much though. 1 over 2x squared minus 5 1 over 2x minus 6. All of that equals 0. Can you see what is quadratic? Anybody able to see what item is quadratic here? Yeah. The item that is being squared is the fraction. So instead of me fooling with this, squaring it, which would give me 1 over 4x, this would be 5 over 2x. Instead of me messing with that, I'm going to replace it with z, anywhere that that item is, which gives me c squared minus 5z minus 6 equals 0. Same exact item as above, isn't it? They did that on purpose. Lost my train of thought there for a minute. Solve for z, and you're going to get the same stuff. Do you guys notice? This is the same so far. Okay? It looks very similar. Z is -1, z is 6. That doesn't mean we're going to have the same solution set. That only means we have the same z value. We still have to solve for x. 1 over 2x is -1. 1 over 2x is 6. Depending upon how you like to do these, whether you like to cross multiply or whether you want to multiply by the denominator, it doesn't matter to me. X is a -1/2 over here, and on the other side, x is 1 over 12. Okay, x is 1 over 12. I always take these and I'll cross multiply, and I would end up with -2x equals 1. That's how I would do it. 12x equals 1. That's just how I do it. You do it however you want. So now we have our x values. The check is left to you. But yes, these both are correct. Do you have any questions about these two examples? These are the simple ones. Fasten your seatbelts because examples 3 and 4 are different. 3x plus 4 square root of x minus 2 equals 0. Please pay attention to this. What item is quadratic? Well, nothing looks to be quadratic to me. I don't know how to make this into something quadratic. This isn't squared. But if I look at this and I say, well, wait a second. If I make the square root of x equal to z, then I can take x and make it z squared. So I ended up looking at this and establishing the relationship that if this is equal to z to the first, then by squaring that value, I get z squared. So this scenario is a little bit different. You actually compare those two terms and find that this is a first power and this is the squared version. You don't realize that, but this and this is squared, this is the root. So these two items can be visualized that way. So replace the items that way. This is going to be z squared, that's going to be z. 3z squared plus 4z minus 2. 3z squared plus 4z minus 2. They picked the quadratic formula. There is no factor option here. There are no factors of -6 that somehow give you a 4, 6 and 1, 3 and 2. So the only option, and completing the square would be a pain because this is an odd I don't want to mess with that. Easiest option is going to be the quadratic formula, which, if you're like me, you have to write it over and over again. And I do. I write it over and over again on everything I ever do with the quadratic formula. It is the opposite of b plus or minus the square root of the discriminant. All of that over 2a. This will allow me to solve for what? For z. Okay, we're not solving for x yet. That's where it gets tricky. We are now solving for z. So the opposite of b, 4. Okay, positive, negative. Plus or minus the square root. B squared, 4 squared, 16. Minus 4 times a times c. All of that over 2a. So rather than dealing with the square root and all that stuff, we've equated the x and the square root of x with z squared and z respectively. 16 plus 24. 4 times 2 is positive 8. 8 times 3 is 24. 24, 34, 40. Sorry. Negative 4 plus or minus the square root of 40. And that goes over 6. And they reduce it. Of course, you can see this is 4 and 10. So you pull the 4 out as a 2. Negative 4 plus or minus 2, 10 over 6. If you reduce, this becomes a 2, that becomes a 3, this becomes a 1, that becomes a 3. And that, my friends, is how they came up with negative 2 plus or minus 3.162 over 3. Now, the reason I just converted this to this is so that you can actually continue working. Okay? This is the value for z. Okay? This is the value for z. This is approximately that. You can see that in the middle of the page. All right? If you solve this and you go with the plus and you go with the minus, so negative 2 plus, that's 1.162 divided by 3, so that would be 0.387, and they have that there for you. All I did was I took the positive, negative 2 plus 3.162, and divided it by 3. That gave me a 1.162 divided by 3, and I got that. Okay, this is the left solution. So if the square root of x is that, by squaring it, I get the x value, okay, which is 15 hundredths. Okay, this is where it gets weird. This, we just did the plus. Now I'm going to do the minus. Negative 2 minus 3.162 divided by 3. So that is telling me that the square root of x is, after I solve this for the negative, I get a negative 1.72. X equals, wait a second, how can the square root of something be a negative? The square root of something is never negative. Okay, we deal with the imaginary numbers. We do that all the time. But we never ever solve a real situation and come up with a negative square root. Okay? So this automatically gets thrown out because when you solve for a square root, the item that is under there has to be a positive. Here, when we squared it, x is equal to that. This item gave us this. You can't have that. That is not going to happen. No solution. So the only item in your solution set is going to be 15 hundredths. See what I mean? It gets really tricky really quick. Okay? Figure out where we're quadratic. The relationship between this and this was a quadratic relationship. this, if this is equal to z, that's equal to z squared, plugged it in, used the quadratic formula. I got to an approximate value of what was the discriminant, added to get this, subtracted to get this, and then you just interpret your data. The square root of something is never going to come out as a negative. Last one, example 4. This one you could go either way. You could do it the way I'm teaching you, or you could leave it as it sits. I really don't care. I have found that both ways work, and it's kind of a matter of what you're comfortable with. These two items, you can see that this squared is that. So if I say x squared equals z, and plug that in accordingly, because this is x squared squared, right? That's x squared squared. I end up with z squared plus 7z minus 18, okay? I took the fact that we can make this z, and by squaring it, I can do that. Solving it this way, you can do it. This one was pretty factorable, z plus 9, z minus 2, gave me my z values of negative 9 and positive 2. Okay? Z is those things. That being said, if I plug in those values here, if x squared is negative 9, then the square root has to be plus or minus 3i when I use that one. The other one, x squared is 2, which means x is going to be plus or minus the square root of 2. Okay? So you've got 4 solutions. Positive 3i, negative 3i. Positive radical 2, negative radical 2. But I always write them just like this. In the book, they might separate them. They do that. But you do not have to. If you write it just like this, I know you mean positive 3i, whoops, negative 3i. And I know you mean positive version of radical 2 and the negative version of radical 2. If you look at method 1, though, on the left, they didn't do it that way. They simply left it as a to the 4th and to the 2nd power, and they solved it, and it's a little bit quicker. With even numbers like this, I've found it's easier not to do this method, but rather to just leave it x4 plus 7x minus 18, because that was factorable. It became x squared plus 9 and x squared minus 2. And you could see how that would be pretty easy. X squared is equal to negative 9. X is plus or minus 3i. Okay? Same exact answer. But it's really up to you. If you like plugging in for z, in this case, do it. I happen to think that the z item is really only valuable in examples 1, 2, and 3. This one here, x squared is equal to 2, which means x is going to be plus or minus the square root of 2. So if you use this method, factor it, you solve immediately for x. If you don't, and you plug in z values, and then you go back and solve for z, or solve for x using z, that's fine too. Yes, we will be doing this again when we return, or tomorrow.